Welcome back to a new data science project. In this video, we are going to build a credit risk model for predicting the risk level of a credit application. We are going to start with data analysis and visualization, then we are going to do feature engineering, and we are going to train machine learning models. And at the end, for the deployment side of the project, we are going to create a Streamlit web app for users to get predictions from the model that we trained. You can see the final version of the app that we are going to be creating in this video from the screen right now. Also, I'm going to be sharing the dataset link in the description of this video. You can follow that link for downloading the dataset. Let's start to the project. Okay, we are in the Kaggle data card of the dataset that we are going to be using in this video for credit risk modeling. And let's take a quick look into it. So it says German credit risk with target, and it says it's a classic dataset of good and bad loans. And I'm going to be leaving this datasets link in the description of this video, so you can visit this Kaggle page, and after registering, or if you have an account, after signing in, you can just download this dataset from this button up in here at the right top. Okay, let's check its page. So at the text we see that we have finance, banking and lending. At the data explorer side, we see that it has version 1 in here, and we have a single CSV file. At the summary side, we can see that one file, we have 11 columns, 6 string data type, 5 integer data types. So we have 6 categorical and 5 numeric data types. And what I'm going to do is I'm going to select all the columns in here. Let's take a quick look. Then we are going to be exploring more about this dataset in the code editor by coding. So we have an index column at the start, then age, sex, job, housing, saving accounts, checking accounts, credit amount, duration, purpose, and risk. By the way, on the risk, good and bad side, good means that low risk customer and bad means that high risk credit customer. So we can think it like if a row like this, let's check the first one. For this credit, we can say that we have low risk, and for the second credit, we can just say that for this credit, we have high risk. So it's like more credit based evaluation. And this is going to be our target column in this project. And let's take a quick look. We have numeric and categorical columns. Okay, so let's analyze it more on the code editor. We are ready to start coding. I'm going to be using Visual Studio Code as my code editor in this tutorial, but you can use any code editor that you want. And here we have the data link. I said it in here for sharing it with you in the description. Now I'm going to download this dataset and add it in the directory in here. Now I download the dataset and add it in the same directory that I opened my project on. And here we can see the common separated values with the columns like age, sex, job to the risk. And what I'm going to do at the first place is I'm going to create a Jupyter notebook named analysis and model. So Jupyter notebook extension IPMB. Now I'm going to select my kernel, a Python version 3.11.4, but you can run other Python versions too. It's okay as long as you have something like greater than 3.1. And let's start by doing our imports of the analysis part. So the order of this video is going to be like analysis, then we are going to do feature engineering, then we are going to do the modeling, and at the last place we are going to create a web app using Streamlit for users to get prediction from our model. And for the starting part, the imports, I'm going to say import pandas as pd, import numpy as mp, import matplotlib.pyplot as plt, and import seaborn as SNS. So these two are for the basic imports that we are going to be using for the analysis, and these two are going to be for the visualization. And I'm going to make it run. Then what I'm going to do is I'm going to set some display settings. These are going to be one from pandas and one from seaborn. So for the pandas, I will say set option, and for the option I will say display maximum columns, and I'm going to say none to it. So it's going to display all the rows when we just call our data, or we just call a featured version of our data. And for the seaborn side, I will say seaborn set style, and I will set like white grid. because I love that style on seaborne plots. Okay, let's start by loading our dataset. I will say data frame is going to be pandas, read, CSV, and I'm going to call the copy relative path in here, and I'm directly going to paste it in here. So we can directly call like dataframe.head for seeing if it's loaded successfully or not. Okay, it seems like data frame is loaded successfully. And let's take a quick look at it. We have the index column here that we are going to drop. It's useless because we also have that in pandas, and we have age. So let's see how age distribution look like. So we can say data frame age.describe, but I'm not going to do that for all of them because I'm going to call describe on the all columns later on this video. So let's just look for the age. The average age is 35 in our dataset, and the minimum is 19 with maximum of 75. Okay, so we have sex, job, housing, and saving accounts, checking accounts, credit amount, duration, purpose, and the risk. So two things I want to tell in here. We have the NA values in the saving accounts and checking account. So what I'm going to do is, I don't care about their count, like how much data points are there with the NA values on this. I don't want to keep NA values in the saving accounts or checking accounts. I can't replace with anything else. So what I'm going to do is I'm going to drop the rows with NA columns, because just checking it, if there's no saving account record or checking account record in a row like this on a credit validation, I think it's better to just remove those instead of trying to replace with a value like leader or no account. So that's going to be the path that I'm going to be following. And also on the risk side, we have the good and bad labels. Again, as we talked in the Kaggle side, the good value in here for this credit rating means that this credit is considered as a low risk credit. So good in here means that low risk, and bad in here means high risk, which is this credit rated as a high risk credit because it has the bad label. Also, let's see the value counts on the risk side. Risk value counts. We are going to see that we have 700 good rated credits and 300 bad rated credits. So it seems like there's a class imbalance when we are going to do the modeling. Of course, it can change with the NA value dropping, but if that's the case, after dropping 2, we need to move with the imbalance handling sections, or if we are just going to use a different model, we need to care for this class imbalance situation. For example, if we are using decision tree, we can just pass the balanced option for the class imbalance situation, like we are going to be talking about them at the modeling section. Okay, so let's continue. Let's call dataframe.shape. So here we have 1000 rows and 11 columns, and I'm going to call dataframe information. So we have like 1000 data points where we have NA values in the saving accounts and checking account, which is I think 400, or I think it's going to be around 500 that we are going to be dropping. Is a huge number for dropping from the data set of 1000 rows. Like we are going to be just deleting the half of the data set, but I'm going to be following that option because I think non-saving account data or checking account data is a pretty important information. So I don't want to rate the credit if there is no saving account or checking account data. So I think it's the best path. So I'm going to keep with my methodology, and I'm going to get the statistical summary by describe, but I'm not going to call it like this. I will say include all for also getting the categorical columns in here, and I'm going to say that T transpose like this, and let's see this. So we have the unique value counts, top occurring values, frequencies of them, means for the numeric ones, standard deviations and stuff. By the way, let's see the unique values of the job. So here I'm going to say unique, and we can see that actually I need to call it like this. So unique values are 2, 1, 3 and 0, which means that the job status like from 0 to 3 it gets like more important job. And also on the risk side we can see the information that we just get. And let's quickly analyze this, the top values. Like on the sex side we have the male with 690 occurrences, and on the housing side the most occurring value is on out of 3 unique values with 730. On saving accounts, most occurring value is little, checking accounts little, and on the purple side we have 8 unique values and the top occurring value is car, and risk it's good. Okay, so let's get to the missing values. I will say data frame is an A. We also got that from the info, but we can see that we have 394 and 183 at the saving account side. What I'm going to say is I'm going to check the duplicated rows also. So I will say duplicated dot sum, and okay, great, we don't have any duplicate rows. So let's just drop the missing values like data frame, drop an A, reset index, and I will say drop true. So at the data frame we are going to have something like this. Now we have 520 rows with 11 columns. We dropped 488 rows. Okay, let's continue with the univariate analysis. And I want to create histograms for numerical variables. So at the first place I will call them, and I'm going to actually let's just drop this unnamed thing. So columns is going to be this. Let me just copy directly for make it quicker. In place is going to be true. So when I call the data frame columns, I'm not going to have an index column. Awesome. So right now I'm going to say age is numeric, credit amount is numeric, and duration is numeric. So let's also verify that. Yeah, cool. So I will say histogram bins, let's say 20, and also I want to say edge color is going to be black. So right now I will call this out like this. Here we see it, and we can also make it look better like PLD subtitle, and I will say distribution of numerical features. And what I'm going to say is I will say font size of 14, and plt.show what I'm going to be using, so we are not going to be seeing this array type of information. Here it is. Awesome. So we can see the distribution on the age side. We have a younger applicants on the credit amount side. We have lower values mostly on the duration side. We have like 10 months to 15 months at the lead. We can change the bins, like I will say 10, and we are going to get something like this. Now we can see clearly. Also let's say like 7. Okay, yeah, we can see the distributions. And right now I want to create box plots, so I will say plt figure, and I'm going to pass the figure size of, let's say, something like a big figure like this, and I will say for index, and then column in enumerate, and I want to go with age and credit amount and duration like this. And after that I'm going to say subplot. I will say 1, 3 and index plus 1 like this. And next up I will say seaborn box plot, and after giving just like position arguments we can create our box plot like y is going to be data frame column that we are going to be iterating on. Like in here you can see age, credit amount and duration. We are going to be taking that, and I want to take the color of sky blue, and also I want to give it a title like this, and at the end I will say title layout, and I want to use plt.show like this. So I think I have a typo. Yes, it's going to work smoothly right now. Okay, awesome. So also let's make this a little bit bigger. like I will say 20 in here, actually 10, sorry. I'm going to have a bigger plot like this. Great. So from our plots, what does it tell to us? Generally, box plots are used for outliers, and in here we can see like older people than 70, and on the duration side we have more like 70 plus months credits. They're probably for the housing, and also at the credit amount side we have like few data points which is greater than 17,500. So I'm curious about the duration side. Let's filter it out and see if they are for housing. So how we can do that is we can directly filter, but I want to show you a different method. Like I will say query, and I will say duration greater than 70. So here we have one data point in here, and it's for radio and TV. Okay, so let's also check for the 60. I think it's okay. If we say greater than 60, it's going to not appear. If we say greater or equal to, here we see with the duration 60 options. They are for business, car, vacation, others, education. Oh, we have no like housing in here. It's strange. Okay, let's continue with the categorical features. So I will say categorical columns, and let's set their names like they are sex, job, housing, saving accounts, checking account, and purpose. Okay, we have that list in here. So let's create our plot. Firstly, I'm going to say for index column in enumerate categorical columns, and in here what I'm going to do is I will say again I'm going to set the just configuration in here, and next I will say seaboard count plot. I'm going to be using count plot because I'm going to working with categorical columns. Data frame, data, X is going to be the column. Let's set the path like set 2, and I'm going to give like an order data frame that columns value counts index like this. Okay, next what I'm going to do is I'm going to give the title. For that I'm going to use a f string distribution of the column that we are iterating through in this loop, and next up I'm going to set the x text 45, and again I'm going to set the title layout like this, and I will use plt.show at the end of this. So it says there is a typo. Yeah, I have an extra space in the purpose. So when I fix this, I think it's going to work smoothly. Yeah, it's looking strange. So let's set like a figure size on the plt.figure, figure size of let's say 15 to 10. So let's see if this solves our problem. Yes, it's solved. So we can make it a little bit bigger too. So I will say 10 instead of 15. Here it is. Awesome. Let's take a look at that. So at this plots we can see that on the sex side we have the male with the most value count. On the job side 2 is the leading one. On the housing side own house is the leading one, rent is second, and free is third. By free I think they meant like living with a parent or something like that. On the distribution of saving accounts we have the Lidl as the leading option, and Rich has the least value, and on checking account side Lidl is leading, moderate it's second, and the purpose is the car is the leading one. So this means that people are mostly applying for a credit for car in our data set. Okay, so let's create correlation matrix. So for that I will say correlation, and I will pass the values of age, job, credit, amount, and duration like this, and I will say correlation. And next what I'm going to do is I will say Like, let's go to correlation. Here we see that, but I'm going to create this with seaborn. So seaborn heat map, let's see this in a heat map, and not true color map, let's say cool warm, and let's set the format of point to floating, and I will use plt.show. Here it is. So let's check these values. So there's no strong correlations in our dataset, and only high value that I see is 0.6 with the duration and credit amount. And we can say from it that if the credit amount increases, its duration is increasing together. So in our dataset with bigger credit amounts, we can say that people are looking for more duration. Okay, so now let's see the average credit amounts by job type and sex. So I will say group by job, and I'm going to group by job for the credit amount values, and I will pass the mean at the end for aggregation function. Here we can see that with job functionality increases, we can see people are asking for more credit in terms of amount. And also let's check this by sex, and I will say credit amount dot mean again. And by gender wise, we can see that male is asking for more credit in terms of amount, female less. Okay, let's create a pivot table. So for that I will say pandas pivot table data frame values, let's say credit amount, and I want to see this compared with housing and purpose. So index is going to be housing and column are going to be purpose. So here it is. By purpose we can see housing wise the credit amounts. So let's check for house owners. By the way, I was analyzing the purposes on this plot, like I was curious on the box plot, like the duration demands, and I just recognized that on the purpose we don't have anything like housing. Okay, it makes sense right now, because generally housing credits are, in terms of duration, they are longer. Like we can see mortgage credits 10 years, 20 years. So I was curious on that side, but I just see that we don't have that kind of information. Okay, so what I wonder is, here on the housing on side, the most of the credit amount demand is on the vacation. Okay, and on the free side it's like, let me check the values, similar. And for the rent side we have like most of them for business. Okay, now let's check the relationship between age, credit amount and duration. So for that I'm going to use a scatter plot, and I will pass my data x like this, and y is going to be credit amount, and I'm going to give the duration as hue, like duration like this. And actually not duration, I'm going to add the hue as sex, because we need a binary or maximum of 5, 10 class variable for that, and size is on duration. And also I'm going to set the alpha as 0.7, and let's set the palette set 1 this time, like this. And next what I'm going to do is I'm going to give it a title, credit amount versus age, colored by sex, and sized by duration. And I will say plt.show. Here it is. So here we can see that at the younger side with the most value, like it's the only value that passes 1700, 500, is female applicant with duration of 30 months. And we can see that we have a well mixed data set in here, and as we can expect, most of the credits are centered around young ages and with the low credit amounts. And generally I can tell from this plot, if the credit amount is increasing, we can see larger dots, which means that more duration in this side. Okay, Now let's create a violin plot. Let's see the create amount distribution across saving accounts. So for that I will say seaborn violin plot data frame, X is going to be saving accounts and Y is going to be credit amount. And next I'm going to set the palette like, let's say pastel one this time. And next I will say title credit amount distribution by saving accounts. And let's use plt.show after that. Okay, so from here we can see that credit amount is not really related with saving account status. On little side we see a similar distribution with moderate, quite rich, and on the width side we have a little bit lower value distribution. Okay, now let's do some analysis for the risk and then we can get to the feature engineering side. But firstly I want to create some columns. I want to see the relations with risk. So firstly let's see the percentages of the risk values. I will say risk, I will say value counts and normalize true like this, and if we say multiply by 100 we are going to see the percentage. We have the 55% good and 44% bad in our dataset. So let's see box plots for numerical features split by risk. For that we will say for index column in enumerate, again we will say age, credit amount and duration, and also after that I'm going to call categorical columns. So we have that list ready. Okay, it's going to be easier. In here I will say 2 dots, next plt subplot 1 3 I plus 1 again, seaborn box plot data equals the data frame, and X is going to be the risk, Y is going to be the column that we are going to be iterating over here. Next we will say like palette, let's use pastel 2. So I'm trying to use different things for you to see every time. I will say plt title and let's give it a title like column and by risk like this. So we are taking the title from here. Okay, let's say plt title layout and plt.show. So it says couldn't interpret input credit amount. Let me quickly check why it is. Yeah, because we have a typo. Now it's going to be working smoothly. And I think we need to set the figure size also, like figure size in the figure, let's say 15:4. And now we are going to see we have it ready. Let's say like 8 instead of this for having bigger plots. Okay, we see that age doesn't seem really related like with the credit risk, and in credit amount we can see that with credit amount increase the bad is at a higher side, and on the duration we see a similar situation. Okay, let's also get the mean values by group. So I will say data frame group by, I'm going to group it by risk, and I will take the values like, I need to use 2 brackets. I will say age, credit amount and duration, and I will use mean at the end. So we can see that for the higher risks, like it's going to be the label with bad, we can see that we have higher duration. So the lower duration is better in terms of risk based on this data, and on the credit amount side with higher amount, as we can expect, it's higher risk. Okay, let's also get this for categorical features. Like I will say for index and column in enumerate categorical columns, I will say plt subplot 3 I plus 1. I will use count plot and data frame. X is going to be the column, hue is going to be the risk, and let's set a palette like set1, and I'm going to give order like data frame, the column that we are iterating, value counts, and I will use index after that, like this. And next up, what I'm going to do is I will give it a title like column by risk, x-text, rotation 45, and I will say tied layout, and I will use plt.show like this. So again, I think we have a typo. Order, okay, so I will say order like this. Now here it is. Also, let's set a figure size like plt figure size of, let's say 10 to 10, so they are going to be bigger. Okay, so let's take a quick look into this, and we can see that, like, let's check purpose. Here on the car side we have lower risk, and only in the education it seems like, no, it's actually 1 2 3 4, yeah, it's education. On the education we have like higher risk on credits, and on the checking account side we can see that the risk decreases with getting to the rich side, and on the saving account side we can say it's like similar, because you can see that the good is more like upper side of the bed compared to the others. Okay, let's continue with feature engineering. So I'm not going to take all of the features from our dataset, so let me code the columns. I will take like features, I will take age, and I will take sex, I will take job, I will take housing, I will take saving accounts, I will take checking account, and next I will take credit amount, and I will take duration like this. And for the target side, what I'm going to do is I will say target equals to risk like this. So I'm going to say data frame model is going to be data frame features plus target like this, because we are taking it without brackets, and I will say copy. So after that we are going to see that we are going to have a data set like this. Awesome. Now at the next step we are going to encode the categorical columns. So I will say from scikit-learn.preprocessing import label encoder, and since I'm going to export these encoders I will import joblib, because I'm going to use them in my Streamlit app. By the way, I'm not going to do any kind of scaling operation, because I'm only going to work with tree-based models and you don't need scaling on those. So we are not going to do an import from preprocessing like standard scaler or normal scaler. Okay, now I will say categorical columns like this, let's say like this. I will say data frame model, and I will use select data types, and I will say include equals to object, and next up I will say columns. And next what I need to do is I will say drop risk, because it's going to have a different setup since it's target. And after that I will say label encoder dictionary, and I'm going to create an empty dictionary. I'm going to add them inside of it later. And also let me show you the categorical columns we have. Here they are. So I will say for column in categorical columns, I'm going to initialize the label encoder like this, and next up I will say data frame model, the column that we are iterating on, and I will say label encoder fit transform data frame model that column like this. Next up I will say label encoder dictionary, and I will paste column is going to be equal to the label encoder that we initialized in here, also used. So next I will say joblib.dump label encoder. I'm going to use a f string. I will say column encoder.pickle. So when I make this run, we are going to see 4 pickle objects in here. So I'm going to make it run, and here they are going to be exported like this. Awesome. Now we are going to encode the target. So for that I will say label encoder target and it's going to be label encoder, same initialization like this. Next up, we can close this. I will say data frame model. I will select the target like this, and I'm going to say, like, let me firstly call the target. Here it is. Data frame model is going to be label encoder target, fit transform. I will pass data frame model target like this. And now what I'm going to do is I'm going to just check data frame model target, and in here we have the 0 on the bad and 1 in the good. So I'm just going to say that data frame model and target. So right now we can see we have the encoded values. If we just say value counts, we are going to see that we are going to have the most one as 1, which is good. So let's note it down to the Streamlit app, like app.py is going to be the file that we are going to be creating. So let me check again. 1 is good, lower risk, and 0 is bad, higher risk. Okay, let's continue from the Jupyter notebook. I will use joblib for exporting the label encoder target. Like I will say like this, and I will say target encoder.pickle. So when I make this run, we are going to see that we are going to have the pickle object at the left. Here it is. Okay, we completed the encoding part, and I will say data frame model.head. So now we have all numeric values in here. Awesome. Again, since we are going to be working with tree-based models, I'm not going to do any kind of scaling, and I will say from Scikit-learn.model selection, I will continue with the train test split. Actually, terrain. And so I will say X is going to be data frame model dot drop. I'm going to drop the target, the risk from here. X is 1, and Y is going to be data frame model target. So at the X side we have this, and for the target side we have like this at the Y side, sorry. So I will just write Y. So in here we have array like this, and in here we don't have risk column anymore. So we will use train test split right now. I will say X train, X test, Y train, Y test, train, test, split, X, Y, and then I will say test size 0.2. I will say stratify Y, and also I'm going to set random state here, because if I don't put that, and if you don't put any kind of random state, we are not going to get the same result, because it can be splitted from anywhere in the dataset. And for all of the processes in this video that needs randomness or that has randomness, I'm going to be adding random state 1. So if you want to get the same results, you can also add that too. So here it is. Let's check X train shape 417 to 8, X test shape 105 to 8. Awesome. Let's import the models, and let's create a helper function to train, tune, and evaluate the models. So for that, I'm going to be using tree-based models again. Firstly, let's say scikit-learn.tree, import decision tree classifier. And I'm going to say from scikit-learn ensemble models, import random forest classifier. And also I'm going to say extra trees classifier. And next up I will say from xgboost import xgboost classifier. And I will say from scikit-learn.metrics I will import the accuracy score for evaluating the models, and for the hyperparameter tuning side I will say from scikit-learn model selection import grid search cross-validation. And if I don't have a typo, which I don't have because it runs successfully, we get those. Next up, let's define a helper function, because I don't want to type the same lines again and again. So if we define a function for one time, then we are going to be cool on just getting the results from models. So I will say define train model, and in here I will pass the model, parameter grid, x train, y train, x test, y test, like this, and like y test, and we are going to be passing those inside the functions every time. Like these are going to be like static, we already have those. We are going to define the models, which we are going to initialize those, and we are going to give the parameter grids. Now in here we will say grid. We are going to initialize the grid inside the function grid search cross validation. We will pass the model from here. We will pass the parameter grid from here. Let's set the cross validation as 5, and we are going to set the scoring as accuracy, like this. Next up, let's set also a number of jobs, -1, so it's going to make it faster if it's possible, based on the computation power we have on our computers. So it can change computer to computer. Maybe your process won't get faster with those. I already explained that in my machine learning playlist. You can check those for seeing this type of parameter definitions. Grid fit, x train and y train. For not repeating everything, I'm not explaining all of this stuff, but for parameter tuning and all of these models, I have tutorials on my channel. Also in the playlist section, I have a machine learning tutorials playlist. You can check those for understanding these concepts better. Okay, we train the model in here. Next up, we are going to select the best model, which means that the best estimator with the selected parameters, we are going to be training with different parameter setups. Best estimator, I will say like this. Y prediction is going to be best model dot predict, and we will pass the x tests for evaluating our results with the testing set, and accuracy is going to be accuracy score, y test, and y predictions. And at the end we will say return best model, accuracy, grid, best parameters. So our function is ready. Let me summarize this. So at the first place, we are passing the model that we initialized, the base model initialization in here. Parameter setup it's different for all the models, and our train and test set. Then we initialize the grid search. Then we train the models, and we select the best estimator, which has the best parameter setup. And after hyperparameter tuning, then we get predictions on the x test, and we compare them with the y test. So we are going to get the best model, accuracy score it has, and the best parameter setup it have. So let's start with decision tree. I will say decision tree classifier, and in here I'm going to say random state 1, because if you want to get the same results you can also pass this. I will say class weights, and I'm going to say this balanced because we have a class imbalance in our target. Okay, let's give the parameters. Grid, and I'm going to define a dictionary, like let's say max depth. We can try 3, 5, 7, 10, and also none. And next, let's try minimum sample split. We can try 2, 5, 10, and you can also extend this lists. I want to go with this setup, leave 1, 2, and 4. So actually we have a typo. Yeah, class weight it needs to be. Okay, awesome. Now it's time for calling our function. Best decision tree, accuracy decision tree, parameters decision tree is going to be train model, because we are going to be setting this returning stuff on those. Train model, we will pass decision tree parameter grid, and also we are going to pass x train, y train, x test, and y test. So when I make this run, we are going to be training our models and doing the hyperparameter tuning. So we have a typo. Let me quickly check. Yeah, here we need to use this lowercase like this, and I'm going to make them rerun, And now we are going to be cool in this side. Okay, now after this we can say like print decision tree accuracy, and let's just go accuracy decision tree. Here it is 0.58, and let's say print best parameters, and we can call parameters decision tree. Here they are: max depth 5 selected out of this, minimum samples leaf 1 selected out of this, and minimum sample split 2 selected out of this. So you can change this list. I want to tell again, we gone with the setup and we got 0.58. Awesome. Let's go with the random forest right now. For that I will say random forest. It's going to be random forest classifier, and I will call random state 1 and class weight balanced again. We are doing this because we have a class imbalance, and let's also set like number of jobs -1 in here. Next up I will say parameter grid. For the random forest, let's add number of estimators, and let's give values like 100 and 200. And next up I will say max depth, and I will say 5, 7, 10, none. And next up I will say minimum sample split, and I will say 2, 5, 10, and minimum samples leaf, I will say 1, 2, and 4. So this is going to be our parameter setup, and in here what we are going to do is we are going to call our function again. So it's saving us out of time on coding these over again and again. So best random forest accuracy random forest, and parameters random forest is going to be train model. We will pass random forest parameter grid, and then the same setup in here. I can directly copy this. It's going to be much easier. So let's see our results. We can say like print when it's training. I'm going to code it. It's doing the hyperparameter tuning right now at the background. I will say random forest accuracy, and I will say accuracy random forest like this. We have 0.61 in the accuracy side, and it's higher than the decision tree. Awesome. And we will say print best parameters, and it's going to be parameters random forest, which are going to be the selected values out of this setup. So for max depth none, for minimum samples leaf 2, for minimum sample split 10, and number of estimators 100. Okay, awesome. Let's continue with extra trees. So for that I will say et, and I will call extra trees classifier, and let's set the random state as 1 again, and class weight is going to be balanced like this, and I will say number of jobs -1 like this. Again I have a typo, it's going to be lowercase. Awesome. Okay, I want to give the same parameters with random forest, so I'm just going to take those and paste it in here. Then I will say et at the start. Next what I'm going to do is I'm going to call my function best et accuracy et, and parameters extra trees train model. I will pass et parameter grid, then our setup at the higher side in here, train test like this. And when it's training the model I will say print extra trees accuracy, and I will pass accuracy et. It's 0.66. Wow, it's the leading one right now. It's better than random forest. And let's print best parameters, and I will say parameters et. So here for the max depth we have none, for the minimum samples leaf 2, for minimum sample split 10, and number of estimators 100. Okay, now also let's try the XGBoost. So I will say XGBoost, and I'm going to say XGBoost classifier with a random state of 1, actually lowercase s like this, and I will say scale weight we don't have something like, let me show you, class weight in XGBoost. So we are going to make it like, give a formula in here, like I will say, let's say like yTrain, where it equals to 0 sum divided by yTrain, where it equals to 1 dot sum. So this is going to be similar for imbalance handling, and use label encoder. We are going to pass false on this option, and I'm going to give the evaluation metric of heuristic loss, and here it is. Okay, awesome. Next, we are going to define the parameter range, like parameter grid, and it's going to be number of estimators, let's say 100 and 200. Max depth is going to be 3, 5, 7. Actually, we need 2 dots instead of equal signs, like let me show you here. Next, what I'm going to do is I will give learning rates of, let's say, 0.01 and 0.1 and 0.2. Next up, I will say subsample and 0.7 and 1. Next up, sample by 3, 0.7 and 1. Okay, now let's call our function with best XGBoost, accuracy XGBoost, and parameters XGBoost. Train model, we will give XGBoost parameter grid, and the same setup like this. So when it's training, I will say again print XGBoost accuracy, and I will pass accuracy XGBoost, it's 0.63, and I will say print best parameters, they are going to be parameters XGBoost. So here we can see that for co-sample by 3, 0.7, learning rate 0.2, max depth 3, number of estimators 100, and subsample 1. So our best model in here, the extra trees, so we are going to work with that on the Streamlit app. Okay, for modeling, these models are enough, and we can continue with Streamlit app creation. But for that, what we need to do is we firstly need to export the model that we trained, because we can get predictions from our model in here, like best ET I can call predict, and I can pass a two-dimensional array, like I will pass xtest in here. We can get predictions, but only in this notebook. For using it in other apps, we need to export that. So joblab.dump, I will say best extra trees, and I will say extra trees credit model.pickle. So we are going to have that in here. Awesome. And I have a tutorial about extra trees classifier. If you want to learn more about that, you can check my machine learning with tutorials playlist. And let's quickly talk about that, because this was the best performing model. It's an ensemble of decision trees that improves performance by using random splits for each tree, and it also reduces overfitting and variance. It is similar to the random forest, but more randomized, which often makes it faster and sometimes more accurate for tabular data, as in our scenario. Okay, let's continue with our Streamlit app. So I already created app.py, so we are going to go on that, and in here what I'm going to do is I'm going to say at the first place we will say import Streamlit as st. Next up we will say import pandas as pd, and also we are going to import the joblab like this. Awesome. Next up we are going to load our model and encoders using joblab. So for that, what we are going to do is we are going to say model is going to be joblab.load. We will say extra trees credit model.pickle. We can also get it by relative path. For making sure, I'm just going to copy that. Here it is, it's the same. And next up on the encoder side, I will say like dictionary mapping, I will say column is going to be joblib.load. I will say f string column, and we say slash encoder.pickle, and I will use a comprehension like for column. In we have sex, we have housing, we have saving accounts, and also we have checking account. So here we read it like this. Next up, we are going to give our app a title like title credit risk prediction app. And next up, what I'm going to do is I will say Streamlit.write, enter applicant information to predict if the credit risk is good or bad. Okay, next up, what I'm going to do is we are going to define the input fields. So for like, let's say age, we are going to say Streamlit number input age, and let's give the minimum value of 18 and maximum value of 80 like this, and let's set the default value like 30. And for the others we will say sex, let's use select box, and like this we will say sex, and let's give it a list like male and female. Next up, we are going to say job is going to be Streamlit number input job 0 to 3 is going to be its label, and let's give the minimum value of 0 and maximum value of 3, and value is going to be 1. Next up, let's continue. We are going to define housing. It's going to be Streamlit select box housing. Our options are going to be own, rent, and free. Next up, we will say saving accounts, and it's going to be Streamlit select box saving accounts, and I'm going to give little, and we have the options moderate like this, and rich and quite rich. I'm not sure these were the values, so I'm going to quickly check. Like I will say in here, let's call the data frame, and let's say on the like saving accounts, let's use unique. So let's see also like this. We have quite rich, rich, little, moderate. Little, moderate, rich, quite rich. Awesome. And next up, let's also check this for like checking account. The options we have checking account, we have its account, we have moderate, little, rich. Okay, so for that I will just copy this in a new line, and we have little, moderate, and rich, so we can remove the quite rich in here. And also what I'm going to do is I will say like checking account, it's going to be like this, and I will pass checking account, and also after that I will say create amount, and it's going to be Streamlit number input. I will say create amount, and I will pass minimum value, like it's going to be 0, and default value is going to be 1000. Let's not define a maximum value to this. And for the duration I will say Streamlit number input duration, also for clarifying things, let's say months, and in here I will say minimum value, and it's going to be 1, and let's set the default value as 12. Let's also not put the maximum value in this too. Now we are going to prepare this input for the model. For that I'm going to say input data frame is going to be pandas data frame, and I will say age is going to be age, and next up sex is going to be encoders sex, and we will use transform, we will say sex, and we will say 0 like this. Next up for job, it's going to be job And next, for housing, we were going to do a similar thing. I'm just going to copy that. I don't want to type it again and again, so I'm going to say this, and I will say housing like this, and I will pass housing. Okay, also we need a comma in here. Now we are cool on that side. Next up we have saving accounts, so I will say saving accounts, and for that I will say this again. In here I will say saving accounts, and at the end I will say saving accounts like this. Awesome. Next up we have checking account, and it's going to be, again, let's just make a copy paste like checking account, and in here we are going to give checking account like this. And this was the last hard one. For the credit amount, we will directly give it like credit amount, and for the duration, we will directly give the duration like this. Okay, awesome. Next up, we are going to create a prediction button. I will say if Streamlit button predict risk, then if the button is clicked, what we are going to do is we will say prediction is going to be model.predict input data frame. We are going to be passing into the model, and we are going to take the output of the model. It's going to be 0 or 1, and we will say if prediction equals to 1, then we are going to say Streamlit success. The predicted credit risk is, and we will say like good with bold text, and we will say like if else is going to work too. Streamlit error, the predicted credit risk is bad. Okay, our app is ready right now. So I'm going to summarize what we do in here after testing it. So I'm going to open the terminal, and in here I'm going to say Streamlit run app.py, and when I make this run, we are going to see something like local URL and network URL. You can just copy this address at local URL and paste it in your browser. Then you are going to see the app that we just created. I'm going to be re-recording in my browser in a second right now in this address. Okay, here I am at the app that we created. We can see the credit risk prediction app in here. I'm just going to go to settings. For showing you, we can change the appearance like white mode or not, or light mode, dark mode. I'm going to show it in dark mode. So we have our title in here, credit risk prediction app, and we have the text in here, enter applicant information to predict if the credit risk is good or bad. And we have our input sections. I'm not going to change anything, and I will try to use predict risk button. Here we can see that we can get our predictions from the model. The predicted credit risk is good. Awesome. So it is working really good. And let's just test the logic of it. Let's say that I want to increase the credit amount but leave everything same. Let's predict the risk. So we can see that right now the predicted credit risk is bad, which means that it's a higher risk credit. So it makes sense. Let's change this to like 1000 again, and let's change other options. Like let's say housing is rent. So let's see if it's going to predict good or bad this time. It says bad. Okay, everything makes sense. So let's change like saving accounts to quite rich and checking accounts to rich. So this time the predicted credit risk is good. Awesome, it's working really good. So let's go back to the code editor, and I'm going to summarize the app for you. Since we can successfully get predictions from app like this. So here I'm not going to use my app anymore. I can close it, and I will start by imports. We have Streamlit for web app, we have pandas for creating the data frame, and we have joblib for loading the pickle objects that we have in here. Next, we load our model using joblib, and we load our encoders into a dictionary using joblib again with a comprehension. Next up, we give our app a title, and we just write text. Next, we use number input, select box, and we get the inputs from the user for the model, then we just set them all together. We use encoders for the required ones, and we define a prediction button, and if it's triggered, we say model let's predict, and we get output and we parse it like it's good or bad on the risk side. Awesome. So this is the project. We completed the analysis, we feature engineering, and we also completed the modeling and the web app creation, and we have a successfully working credit risk model right now. Thanks for watching. Let's get to the outro. Thanks for watching this data science project. I'm sharing new videos about data science every week, so you can subscribe for more videos like this. Also, I have a data science projects playlist where I have more than 40 videos just like this one. You can check that playlist from the cards of this video or from the links in the description. Have a great day.